G'day, this is the Memory Health Made Easy podcast, episode 11, and what a great conversation today we have in store. I'm joined by Professor Zoltan Sarnyai, and he gives me grace to say that that's a reasonable approximation. He is a medical trained PhD neuroscientist with a real research interest and program in neurobiological mechanisms of stress and psychiatric disorders, including addiction, schizophrenia, and depression. He has also, prior to his role at James Cook University here in Australia, was university lecturer in pharmacology and fellow of Pembroke College at the University of Cambridge. He has been awarded the Kurt P. Richter Prize by the International Society of Psychoneuroendocrinology for his work in neuropeptides and brain function, and was a recipient of the prestigious DuPont Warren Fellowship from the Department of Psychiatry at Harvard Medical School. G'day, this is David Norris, and this is the Memory Health Made Easy podcast, brought to you by memoryhealthmadeeasy.com. Easy to remember, isn't it? Professor Zoltan brings an entertaining, rich conversation in understanding stress, allostatic load, which will be a new term that many of us are being introduced to, which we could say is wear and tear, and how that plays out on our cognitive fitness for life. This is a deep, wonderful, engaging, and I find a stimulating conversation. So join me on today's show at Memory Health Made Easy.
This is the Memory Health Made Easy podcast, the show where you learn practical tips and experts share advice on what you can do to boost your brain span to match your lifespan. Now to the host of the show, David Norris.
Today I'm joined on the Memory Health Made Easy podcast with Professor Zoltan Sarnyai, and he has given me his lovely grace pre-conversation to say that's about as good as I'm going to get. So I'm going to ask Professor Zoltan if he could, give me a little bit of a background about, you're obviously a passionate neuroscientist. You've been in this space in exploring brain health, mental health, gut health, the whole ecosystem of influences around, I guess, cognitive fitness and chasing that holy grail around prevention. How did you get into this wonderful work, Professor Zoltan?
Yeah, so that's really interesting. I went to I was born and grew up in Hungary, and I went to medical school there. So first year in medical school, you really have to memorize a whole lot of facts. And by the end of the year, I sort of got disillusioned with it. And we also had to do a month's hospital internship after our first year, and that was quite scary actually. So I had sort of misgivings about my choice, but I thought, okay, let's give it a try. Let's go on and try to do some science in the meantime. So since I was the first one in the family in medical school, I turned to a friend of mine whose father was the professor of medicinal chemistry in our university, if I could work in his lab. So I ended up working in a medicinal chemistry lab, synthesizing peptides. So they are made up of amino acids, and these were very simple peptides, very short peptides with 3, 4, 5 amino acids. And I was really crap at it. I never really managed to synthesize a proper small peptide, but during my time there, I came across on the lab bench of a PhD dissertation written by another colleague of the same university about the effects of neuropeptides on brain function, mostly on learning and memory. So in my spare time, while the synthesis was going on and I was waiting for the peptides to come out in the end, I read this dissertation and I thought, wow, this is exciting. So that's what I want to do. So I went to see this professor at a different department and asked if I could join his group. And I did next year when I was in my third year at medical school. And I've been in research ever since. And that was really an eye-opener for me, because I realized that I'm really interested in understanding how the brain works. And of course, we are very far from understanding it. And I wouldn't claim that I understand really any of it, but it's the most exciting endeavor I can imagine. I'm trying to to understand what makes us what we are, humans with our high level cognitive functions, our complex emotional lives, and all that. And it all started through these relatively simple little neuropeptides. And these neuropeptides happen to be acting on the brain and the body's stress reaction. They were oxytocin and vasopressin. So I started to work on these neuropeptides in the context of drug addiction as a student, but that really piqued my interest about stress. And I started reading about stress. There is a famous figure in 20th century stress research called Hans Selye. So he was Hungarian originally. He was called János Selye in Hungarian. So he left Hungary while he was still very young and went to Montreal and established himself as one of the biggest names of mid-20th century stress research. So he had a book. The English title of the book is The Stress of Life, which I read in Hungarian translation. And looking back to the scientific content of the book, it is now very outdated. We have very different knowledge and understanding of stress now, but just his enthusiasm was infectious. So he was obviously a workaholic, might have been a little bit bipolar as well, just reading about his own life, because the stress of life is basically reflection on his own life and his research. So that made me even more interested in these aspects of stress research. And these things usually happen by accident. And around 1990, I think, I was a few years out of medical school working as a young researcher and a young academic at my university back in Hungary. A colleague of mine showed me an article in the Hungarian edition of Scientific American, which actually just started around those times. And it was an article written by a young scientist, Robert Sapolsky, at that time. So Robert was a postdoctoral researcher at the Salk Institute, and this colleague of mine shared the lab with him while he was at Salk. So he showed that article to me. Zoltan, read this. This is really interesting. And this is about Sapolsky's work in the Serengeti, looking at the social behavior of the wild baboons and the impact of their place in the hierarchy on their stress level and general health. And I thought this is fascinating. And I have been really fascinated by how the environment influences our whole body, and within that, our brain. So that's basically the long story and the long answer to your short question.
Zoltan, the thing that I get from reading your immense body of research is that you've very much had an investigative focus around those key points of stress and our relationship with the environment. And I noticed that they're teasing that out further. You talk about the role of how it shapes the brain, this interaction with the environment and our perception and engagement with that environment through the different processes that fall out around hormones, our immune system, metabolic factors, and how that comes to play in then those cascade of changes when we start to see things go wrong with our brain health, when things start to manifest as depression or early stage memory loss, etc. When you're looking at that landscape of those different factors, what are the things that really stand out for you at the moment of where you are in your career, of those factors that you wish people probably knew a little bit more about, or fascinate you because more and more that you're attracted to that piece of life, be it in the environment or our internal makeup, are starting to show you some interesting things that become possible levers for us to influence?
Right. So let me start a little bit at an earlier stage to answer this question, because what really fascinates me, how the concept of mental health and the brain in relation to the rest of the body has evolved over time. So if you look back historically, people assigned different organs to mental function. So this is why you have terms like gut feeling or listen to your heart and these sort of things, because that was how people envisioned our what you would call now higher cognitive functions and emotions to be represented in our body. And that had changed. That had changed towards the 18th and especially 19th century onwards. And we did realize, or our forebears realized, that these higher cognitive functions, emotions, somehow are generated in the brain. And that completely shifted the interest, and almost exclusively, especially in the 20th century, to the brain, and for a long time to the brain in isolation. Although all the medical students are being trained about the actual physical links through nerves, hormones, immune mediators between the body and the brain. But still, when brain disorders are being conceptualized, psychiatric disorders, they are conceptualized as something related to brain function, as opposed to related to this interaction between the brain and the body. And I think this is fascinating. And we are more and more realizing that the brain is not working in isolation. The brain is one organ in our body of the many organs. It happens to be infinitely more complex than the liver and infinitely more complex than the kidney. It happens to be doing things that these organs are not doing, like electrical activity, generating memories and all of that. But in principle, it's part of the same large system. And the communication between the brain and the different parts of our body, I wouldn't say bidirectional, it's really multidirectional. And we still don't understand a lot about these interactions. Let's just give you one example, and that's the gut microbiome. 10 years ago, nobody had a clue that the gut microbiome, the trillions of bacteria living in our intestinal system, have anything to do with our higher cognition. We had absolutely no idea. And I remember when I was at medical school, I always looked down on gastroenterologists. So what comes out of the gastrointestinal system, and what comes out of our brain, those are the higher human functions. But in fact, maybe they are up to something, because those trillions of bacteria have a lot to do with how our brain functions. But the other way around as well, our brain interacts with the microbiome in a fashion that the brain directs the local environment for these bacteria to change in a way that interferes with their total general makeup and therefore their functionality. And I think this is almost like a sea change in our understanding how the brain interacts with the environment.
And I think that's one of the missing conversations that is happening around the gut biome, that everyone's probably loudly speaking around the association of the gut communicating to the brain. However, what you are saying is it is multi-dimensional communication that's occurring, and we cannot negate the role of how the brain is also talking to the gut, and quite possibly the rest of the body talking to the gut as well.
Yeah.
So one of the things that I remember hearing you speak about at the Lifestyle Medicine Conference some years back was your work in brain trauma. And that fascinated me on two fronts, because at the time I was working in and quite closely with folk that had experienced mild cognitive changes as a result of trauma to their brain, be it car accidents, sporting injuries, or assaults, for example. And as a clinician, I would often struggle at the myriad of presentations that were happening in folk, which is a long, long way away from what you would expect symptoms to be, due to the mechanism of injury and how it has affected the tissue. So, and in that conversation, you spoke about stress in the system and how that is then influencing change structurally and behaviorally in brain and gut. Could you talk to us a little bit about your work in that area?
Yes, so even if we would like to separate an actual physical brain trauma from, if you like, the psychological aspects, although I'm not a prescriber for this sort of dichotomy, because whatever is psychological is obviously the product of the brain, but what you would call sort of psychiatric. Let's say if you suffer a car accident, which occurs very often, or if you serve in the army and you are in deployment in Afghanistan and terrible things happen, mines blow up next to you, you get a physical injury in one hand, but you have another kind of injury at the same time, which may manifest itself as post-traumatic stress disorder later on. It might not, but still it's a major stressful event. So it's really hard to separate in a real life condition. If you want to study it in a lab, you can apply a physical force to the head of a rat and you can induce, which is called a mild traumatic brain injury. But in humans, usually these injuries are occurring within the context of psychological trauma as well. So it's really very hard to separate the two. And probably that complicates the intervention as well. If you consider the dichotomy or the separateness between neurology and psychiatry, traumatic brain injury, okay, that's neurology. And that's a different profession than the ones dealing with the post-traumatic aspect of that, the stress disorder aspect of it. And they are probably inseparable. And if you look at the underlying biology, traumatic brain injury induces changes in the brain that are related to inflammatory processes. Activation of pro-inflammatory cytokines, astrocytes, that are there in the first place to heal things or to get rid of the cells that are dying and are not needed anymore. So in that sense, they serve a beneficial purpose and an evolutionarily advantageous purpose. But at the same time, these highly biologically active chemicals like pro-inflammatory cytokines, interleukins, and interferons, tumor necrosis factor alpha, and all that. These are highly biologically active molecules. In other words, they disrupt cell function, they disrupt cell communication. So there will be effects that are beyond the sort of the housekeeping role of these inflammatory processes. And this is not that very different what happens during a chronic psychological stress and trauma. So that occurs in the whole body as well as in the brain. We know that chronic stress opens up the intestinal wall and leads to something that is called the leaky gut. And that allows bacteria that normally should live in our intestine interact with the bloodstream. And once they interact with the bloodstream, our immune cells recognize them and they start producing these highly biologically active cytokines. And these cytokines go up to the brain and they are able to activate our stress biology. So the hormones that initiate the stress response, like corticotrophin releasing hormone, CRH, are responsive to these circulating cytokines. They get out of the brain and they will stimulate our hormonal axis to have more cortisol. So this is why I'm saying that these things are really highly interconnected. And they are interconnected in a non-linear fashion. And therefore, it's difficult for us to conceptualize because it's a lot more easier for us to understand something that is linear in its logic. But this is likely to be like a network activity, which is much more difficult to grasp conceptually, especially for someone like me who is mathematically challenged. Yes.
you and me both. I guess as somebody who's on this journey, much like yourself, about fascinated by the things that influence our cognitive performance. When you say that we don't know much about the brain, we are certainly more advanced from where we were 10 years ago.
Of course.
And the concept that I often refer to is thinking of it as flight. And I put this out a couple of episodes ago in another interview about, if you're thinking about the development of flight, there was Icarus who had his waxed wings with feathers on it. And then we moved through to creating the first concept of a plane, which didn't really take off. It was more like a glider. Then we put a motor on a cardboard setup. And then all of a sudden, we've progressed to putting people on the moon and thinking about Mars now, for example. Where are we on that spectrum? And I postulated that we're just thinking about flight off the ground. And as somebody said to me more recently, he said, Dave, we still haven't even put wings on yet. We still haven't put wings on in terms of how far we've got to go. I guess that gives folk a good example that we are still trying to grasp a very complex and dynamic system, which it sounds like has more variability individually than generically across a group. When we look at a cluster, we might see more variability in one person compared to the next due to their potential to deal with that load, that stress load, that allostatic load. And do you see, what are the factors that contribute to the demand, the ability to deal with those different stress volumes? For example, the classic one that you provided us there with the soldier who experiences an explosion, has a concussive force, experiences a brain injury. One person experiences post-traumatic stress disorder, the other doesn't.
That's right. That's right.
What are the variables that are contributing to our stress resilience? And
so
what
it is absolutely fascinating. And I could say this is the $1 million question, if you'd like. That's how much the Nobel Prize pays you. But I think we are really just at the beginning of understanding the potential basis of these individual differences. But you're absolutely right. There are considerable individual differences. And the military example is a very good one. Even if you are not talking about a physical injury, if you are talking about, my friend being shot next to me, and a week later, another friend of mine who I share a tent dying in front of me, this is a huge emotional trauma, and myself continuously being threatened to die. So that's a huge emotional trauma, which leads to PTSD in about 20% of people who are exposed to it, but not to the rest of the 80%. So why is that? So what makes an individual more resilient, or what makes an individual more susceptible for the long-term negative consequences of stress and trauma? When I'm saying that it is the combination of genetic and environmental and early environmental factors, it sounds like a cheap way out, but it's probably really what it is. Our genetic makeup does contribute in our susceptibility or resilience to stress. And we know that from animal studies. So animals do not, experimental animals, they do not live such a complex life as we humans, and we can control pretty much all aspects of their lives. At least we think we can control all aspects of their lives for experimental purpose. And there you can clearly demonstrate that if you have two mouse lines, and these are inbred strains, they are genetically very different from one another, but within a strain, they are identical. They are as genetically identical as they can be because they have been maintained by brother-sister mating for the last 100 years. So they are pretty identical genetically. And if you compare the stress response of one strain to another, there will be very big differences. Not likely to, not 100%, but likely to be driven by the genetic difference. So we know that. And there are a few genes that have been identified in humans that may play a role. And some of these genes are actually related to our biological stress axis, like genes that interfere with the cortisol receptor in the brain. And obviously, they were studied because they are quite obvious targets. And it's very likely that there are dozens or maybe even hundreds of more of these genes that have to have a certain makeup in order to produce a more resilient or a more susceptible individual. Having said that, from a very practical point of view, we can't do much about our genetic background, really. That's what we have. But we can do quite a lot with what happens to us. And these environmental factors that are interacting with our body and brain throughout our entire existence. And when I'm saying that, that includes prenatal life, so before we are born. So during pregnancy, a lot is actually happening. A lot happens between mom and the fetus. A lot happens between environment, mom and the fetus. And it's not just emotional stress. It's actually environmental toxicants like alcohol, nutritional factors. It's known that very low protein containing diet during pregnancy will have long-lasting consequences on the offspring health, both physical and mental health. And there are unfortunately large, big studies being done related to the Dutch hunger winter during the Second World War and the Cultural Revolution in China, offering millions of individuals to study, unfortunately. So we know that these factors do play a role in the development of the brain, as well as the development of the relationship between the body and the brain. So these factors, they all shape what we are. So by the time we get to the situation of the trauma happening to us, the response will depend on a stochastic combination of all of these factors. Yes, we can design nice and clean experiments, and yes, we can study identical twins to tease out the contribution of genetic factors, but we still are at the beginning of understanding how these factors work together.
Zoltan, one of the studies that popped to mind is that lovely populational data sampling that happened in that Swedish community. And I've forgotten the name of that. I should say famous because it's not famous to me right now. But that study with regards to in the 1800s, they had such rich data sampling, fantastic data about the community's exposure to famine, delivery of goods, delivery of trade, the maintenance of trade, what happened to a community from a health and illness perspective. And they kept that data. And I guess one of the wonderful things that came out from that was that what happened to great-grandfather and great-grandmother influenced generations later. And so, you know, whilst you've painted that development of the fetus from mum, there's also a long generational influence of epigenetic, those things that get which turned on or off in regards to what the people were exposed to. Taking all this in, gosh, it's complex.
Yes.
Gosh, it feels overwhelming that I don't have any control given the scenarios and given how I'm made up. But we know that's not the case, that you are in somewhat control. And I guess one of the quotes that I'm going to put you on the spot here, Zoltan, because I pulled this up, that you've been known to say, careful tending of our brain through optimal nutrition, exercise, both physical and mental, reducing the impact of traumatic events and toxic stress will result in a more resilient brain for life. Do you want to expand a little bit more on maybe those optimal elements there so that, I guess, you know, we've got such a dynamic system at play here. It's fascinating. I'm super excited because I feel like I'm starting to get a peek behind the curtains that have been closed for so long. What are the things from your perspective are going to add to that sort of optimal element of living?
It's actually very sort of strange of me to say that because I'm employed as professor of pharmacology at my university, and this is what I teach for my salary. I teach pharmacology for second-year medical students, and that is about drugs, how drugs interfere with our body to treat diseases. And now what we are talking about is something completely and entirely different, which doesn't mean that drugs are not important. But I think what we are talking about is more on the side of the prevention. So what can we do in order to prevent something down the line happening to us that is detrimental to our health, physical and mental health? In medicine, prevention is the most effective intervention, and probably it is the most cost-effective intervention. In many areas of medicine, prevention is around already and has been around for quite some time. Mental health is not among them. It's not among them. But if we assume that these systemic factors, what we have been talking about, stress, emotional stress and trauma, nutritional factors, inflammation, infection, and all that. So if these factors, they all shape the brain for the better or the worse, then we potentially have a handle on prevention in the long term. there is a tremendous amount of investment going into identifying genetic basis of complex disorders. My fear is that even if we have an understanding of the genetic makeup of a complex chronic non-communicable disease, such as schizophrenia or major depression, we know that that will only explain a percentage of the condition. It's not the number of conditions, but the factors involved in the condition. If I have a little bit of time, I'll give you an example.
Please.
Why I think we need to be a little bit skeptic here. And my favorite example is Huntington's disease, which is a terrible degenerative neurological disease, ultimately leading to death. So we know it's an autosomal recessive disease. We know it's a single gene. We know the identity of the gene. And we identified that in the 1980s. We know what the gene does. We know the protein Huntingtin and its role in cellular physiology. And there is not a single drug we have been able to develop on the basis of this knowledge. So the only thing we can do prenatal diagnostic, and we can tell mom that your son will die a terrible death at the age of 40. And this is awful. This is really, really awful. And that is an eye-opener, actually, towards factors other than the genes that contribute, because genes are very hard to change. There are conditions where we soon will have the tools to manipulate even the germline, if that's ethically allowed, and we can eliminate single gene disorders, and that's going to be a huge, big step. And maybe Huntington's will be like that. But I think in the meantime, we need to look at some really interesting studies. My colleague at the Florey Institute, Tony Hannon, published a wonderful paper some time ago describing a transgenic mouse line that was expressing the human Huntington's disease gene, the trinucleotide repeats that leads to Huntington's disease. And these mice developed the full human condition, and they died very early. So what Tony Hannon did, they exposed these mice to exercise and complex cage environment, and they were able to delay the neurological deterioration of these animals with an environmental manipulation. It is really not important if it's Huntington's disease and what kind of manipulation that is actually, but just the fact that you have a genetically determined, not genetically contributed, it's genetically determined condition, which you can manipulate for the better with that environmental intervention. I think this is fascinating. And that is the example that can be actually translated to many other areas of psychiatry and neuropsychiatry. We know, for example, that early environment is key in the development of the brain, therefore in the development of mental health and mental illness later on. In our human life, the first 3 years are critical, as well as the 9 months before that. It's very, 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 very critical. And nurturing makes a big difference. And nurturing here means love, parental love and attention, holding and folding the baby and loving the baby, but just as much providing the baby with the right kind of nutrients early in life, vitamins, and cognitive stimuli. There are unfortunate experiments of nature throughout history which allows us to study the long-term consequences of early neglect. One very good and tragic example is the case of Romanian orphanages in the 1980s. So in this communist country, they wanted to increase the number of populations, and they banned all birth control. And if you ban birth control, then you will have more babies. It's a communist dictatorship it was, so they could do that. But in a poor country, all of these unwanted babies ended up in state-run orphanages. And these orphanages were terribly poorly resourced. 100 of kids for one person in beds that were almost like cages, complete physical and emotional neglect. And after the political changes in 1990, and the civilized part of the world got to know about it, and many of these kids got adopted by families in Western Europe, US, Canada. And a very clever research group at Harvard actually followed these kids and followed their development after they were adopted. And yes, there is a tremendous negative influence of the early neglect. But yes, there is a tremendous positive potential of a nurturing environment after. The major thing they learned from this study is that earlier this nurturing environment kicks in, the better the prospect, the neurodevelopmental prospect of this individual. So I think there are lots of things we could do. Environmental enrichment, this is how you call it when you deal with rats and mice. Paternal love and loving family, that's how you would call it when you talk about humans. That is important. And the balanced diet is tremendously important. Again, I'm not a nutritional expert, so I wouldn't be able to give you a meal plan of some sort. But we do know that high fat, high carbohydrate diet is bad. And it is bad because it creates a low-grade inflammatory response in our body, probably due to the fact that this leaky gut syndrome develops and the gut microbiota will be completely reformulated under these nutritional conditions. And this low-grade inflammation in the body is not a good news. So many chronic disorders, including metabolic syndrome, type 2 diabetes, obesity, but brain conditions such as major depression also seem to be contributed by factors related to this low-grade inflammation. So here we can tie an unhealthy dietary pattern to systemic and brain ill health. And we do know on the other side that high fiber, what you would call Mediterranean diet, is a good thing. So funnily enough, we can't digest fiber. That's why we have the bacteria in our intestines. They do the fiber digestion for us. They break down these complex long carbohydrates, fibers, into short-chain fatty acids. And these short-chain fatty acids, propionate, butyrate, they are highly biologically active. And they do a whole bunch of good things in our body and in the brain. And we are just beginning to understand what they do. And some of the effects they have are actually related to the epigenetic modifications we have been touching upon, how experience can be traced back through generations. And these short-chain fatty acids do act on epigenetic processes in the body and in the brain. So yes, we know that there are kinds of foods that are definitely bad and there are kinds of foods that are definitely good. Exercise, the other thing you highlighted in the quotation. So again, in a human setting, you can make all sorts of arguments. Yeah, people who exercise, they are upper middle class, they have all the time to do their exercise, they are sort of cognitively more aware of their situation. So yes, they are better off, but they have been better off before. So it's not the exercise. But if you do that in rats and mice, you can't use the same argument. So rats and mice benefit from exercise, benefit from physical exercise. A very famous study was done at the beginning of 2000s when we started appreciating that there are new neurons, new nerve cells are being born in our brain during our whole adulthood in one particular brain area called the hippocampus, which has a lot to do with learning and memory. And at that time, a group in California demonstrated that if we expose these mice to physical exercise, we put little running wheels into their cages, that they run a lot, they actually enjoy doing it, then they have more of these newly born cells. And it is highly likely that having more of these newly born cells in the hippocampus contribute in their better cognitive fitness, if you like. And we have every reason to believe that the same thing happens to us in humans. Even in really devastating psychiatric conditions like schizophrenia, a good body of research is emerging to show the benefit of exercise. And this is on top of being antipsychotics and all that. Physical exercise leads to symptom improvement, not only not gaining as much weight as a result of the second generation antipsychotics, but also improving in their cognitive, emotional, and behavioral measures as well.
Wow, a lot of stuff in this episode. Be right back into it. I want to share with you a little bit about memoryhealthmadeeasy.com and what you can find over there. Programs, resources, and community, all with one goal: to help stop avoidable memory loss. Here's a great place to start. The Memory Health Checkup shows you how to identify your personal risks and also set a map and course about what to do about them. The Memory Health Fast Masterclass gets you out of the gates quickly around applying the 9 principles for memory health for life. Want to work out your brain? Improve your brain performance with How to Train Your Brain. It's a 30-day brain optimizing program. And of course, we've got our flagship community, which is all about support, and you can ask me any question, where I'm your memory health coach to guide, support, and cheer you through the steps to achieve memory health. Come on over to memoryhealthmadeeasy.com/products where you can find out more. Now let's get back to today's episode.
I think to add to that, Zoltan, and I read, I think it was this year, an extension of that paper that you referenced around the identification of birth of baby neurons with regards to exercise, that there was an observation also that with exercise, obviously we get a greater number of neurons appearing ready to mature. What they also found was that coupling that with mentally challenging exercises as well was then associated with the development into a maturing of that neuron, so they didn't die. So there was an observation that exercise appeared to have a link with promoting neurogenesis, the development of neurons, where that environment that presents cognitively challenging, mentally stimulating elements to it then appeared to be associated with the maturation and increasing connections of those neurons. I also think of Dr. Rasmussen's work on the role of exercise and mental health, and especially with folk who experience chronic mental health will often be more markedly impacted by negative lifestyle choices as well: poor diet, smoking, alcoholism, drugs, etc. And obviously, exercise can be one of those routines and behaviours that enables people a step out of that routine, step out of those behaviours. Another paper that popped into my mind as you were talking today around the environmental enrichment came out of just recently published, was a group of scientists that went to Antarctica, and they looked at their hippocampal density before and after. And given that they're away for, I think it's 60 days, low light, locked in a room, repetitive behaviours, no stimulation, same tasks, etc., they observed a 10% change in the hippocampal density. So for folks listening to this, that means that for the hippocampus that we often point the finger to as being one of the key learning areas or organs responsible, or parts of our brain responsible for learning, they had a shrinkage in that area. And this is a group that you would think had a very rich, dense, and robust area. It just demonstrated that the brain changes depending on what we give it.
That's right. Yeah. I think that's probably more important at present to appreciate that the brain is able to plastically change to the worse and for the better as well. Although we may not quite understand what's the functional consequence of having a 10% volume reduction of the hippocampus, we assume that it's probably not a good thing. But the bottom line is the brain is very plastic. And we always talk about stress and psychological trauma as something awful to our brain and the body. And that is beyond a certain level of toxic stress. It is true. But I think it's equally interesting to figure out what we can do against it, how we can increase resilience or coping strategies, because we can't really aspire to eliminate stress and trauma from our lives. This is just part of our lives. You drive home and you got rear-ended by a huge big ute with the bull bar. It's very traumatic and it could happen to anyone and we can't eliminate it. So what we can do, hopefully, we can devise interventions that help individuals to recover, to become more resilient, and cope better with the consequences.
So now that we've covered the territory of a very complex situation in regards to how our whole body works, in regards to the influencing factors that can impact our cognitive fitness, what's exciting you moving forward about your work and in this space, especially around stress and mental health? And I noticed that you often tip the hat to some exciting things in technology as well, and how that might come to play a part in getting more rich data so that we can make better changes. And I guess from the way I see things, it has a relationship. When we have more informed data, we can create that physiological resiliency, that buffering element that we can walk through life with in a better balance. Like if you can see me at the moment, I'm waving my hands like a dancer at the moment, which is demonstrating that we've got more capacity to move through these extremes, but still retain good sense of overall performance in terms of our cognitive ability for us to perform complex problems, maintain a sense of equanimity, that through these difficulties there is a sense of evenness. Tell me about that at the moment with regards to what's exciting in your work.
Yeah. So I think I can give you the answer to this question at two different levels. One is what we are doing in our lab. So that's the actual projects, what we are currently doing and planning to do in the near future. So for example, integrating different biological measures into some sort of index which we can use to predict either the disease development or treatment response. That's one of the main interests in our lab. And in that regard, we work within the concept of allostatic load, which was developed by Bruce McEwen at Rockefeller University when I had the fortune of working with Bruce for 4 years in the second half of the 90s and still collaborating with him on several of our allostatic load related projects. So
can I ask, just to interrupt you there, for the folk that aren't familiar with the term allostatic load,
yes,
could you explain that?
Sure. So allostatic load is the wear and tear on the body. So if you imagine our body as a physiological organism is trying to respond to everything that tries to move it out of balance. And some of the responses are instantaneous and it doesn't cost anything to the body. But many of the other responses carry a physiological cost. So I just mentioned the activation of pro-inflammatory molecules. So they become active because they have a physiological role. But if the stress is chronic, long-term, and too high level, then a lot of these highly biologically active molecules do a bunch of bad things to the body, to the immune system, for example. I'll give you another example, cortisol. So cortisol is your well-known stress hormone in our body. And cortisol is not a bad guy. Cortisol is a physiological guy. It's in there in order to help us to respond to the environmental challenges. But the type of environmental challenges we are exposed to in our 21st century life are completely different to the ones this physiology we have was originally designed for. And the result of that, so cortisol is a highly biologically active molecule. So think about it. We give cortisol to suppress immune function in people we prepare for bone marrow transplant. We use high doses of cortisol as anti-inflammatory agents and all of that. So it's highly biologically active molecule. So if it hangs around in the body for a long time due to chronic and toxic level of stress, there will be negative consequences. And this is what allostatic load measures. Allostatic load measures this multi-system dysregulation that occurs over time. So hormones, the autonomic nervous system, our heart rate, blood pressure, our metabolic functions, blood glucose, insulin, circulating lipids, and it combines it into one single number, and that's the allostatic load index. So we are engaged in research related to understanding how we can use this to predict emerging mental illness later on in several different settings. So we published a couple of papers in Australian indigenous setting, looking at allostatic load and the links of allostatic load to mental health. And this is not a clinical sample, this is a community sample. And we were able to demonstrate that elevated allostatic load, which is the summation of all the sort of the physiologically bad things that are happening to us. So elevated allostatic load correlated with several aspects of depression. So anhedonia, inability to experience pleasure, is a central feature of depression. It's correlated highly with elevated allostatic load index. And in this particular population, we are talking about young people between 15 and 25. So already in their youth, there is an accumulation of environmental effects into this elevated allostatic load. And yes, correlation is never causation, but there seems to be a link between this elevated allostatic load and their mental well-being.
I wonder that the 2017 paper by The Lancet, which published the lifetime risk factors associated with increasing one's risk for dementia, that they showed that if we got a handle on these lifetime risk factors, that we could potentially see up to 35% reduction in presentation of folk experiencing dementia. That's 1 in 3 people, roughly. When looking at some of those key pillars of that key publication in 2017, it was midlife depression that represented one of the large risk factors for experiencing dementia later, cognitive decline later in life. And I wonder, and I'd appreciate your thoughts on this, I wonder at the association, I'm not saying cause here, I'm wondering at the association around the allostatic load in the population. So folks, for listening, just to repeat that again, it is around our wear and tear of our systems. And that may be expressed from our hormone levels, our metabolism markers, our glucose regulation, for example, our thyroid function. All of these things, as Zoltan's referring to, adds up to this number. And that is representing the wear and tear, and it's called the allostatic load. The allostatic load and its relationship to depression. What is that? What does that look like population? You've pointed the finger at and you've made that observation in the Indigenous population here in Australia. What do you see that as across the board? Is there a strong confidence in that observation around higher allostatic load is observed to have a strong association with mental health issues?
Elevated allostatic load has actually long been associated to cognitive decline during elderly. There are a number of longitudinal studies by the MacArthur Foundation in the United States, led mostly by Teresa Simon from University of California, San Francisco, in which they are following a large group of elderly individuals, calculating their allostatic load index and measuring their cognitive procession during the old age. And it's been actually quite firmly demonstrated that elevated allostatic load predicts cognitive decline, which is not terribly surprising in the sense that an elevated allostatic load means that some of the mediators, which if they are there in excess for a long time, are harmful. So these mediators, biological molecules, are on the higher end of the spectrum. So therefore, they will exert negative biological effect on the whole system. And if you focus on the cognition, then you will see that in the cognitive function arena. And the link between midlife depression and later cognitive impairment, this is again not terribly surprising, but it's very important to see and acknowledge that this link is there, because while cognitive decline in old age might be very hard to do something with, depression during midlife may be more manageable. And targeting that, we can prevent some of the later negative cognitive consequences. So the very same brain circuits that are involved in depression, prefrontal cortex, amygdala, hippocampus, they are also involved in our high-level cognitive functions. So if these systems start misbehaving, if you like, biologically during midlife and gives rise to a symptomatology which we call depression, then it is not surprising that as time goes by, the progression of the same biological processes can impact on cognition. Having said that, major depression is also characterized by certain degree of cognitive impairment. So people are usually not at their cognitive top when they are going through a depressive episode.
Zoltan, with your work, we've obviously mentioned those markers of wear and tear in the body as part of what the lab's looking at the moment. I also wonder around the relationship of the sleep and how sleep as a behavior, but a critical behavior for, I guess, maintaining, supporting, repairing as an outcome of what we do of sleep. There are these things that are occurring at a cellular level, at a system level, at a neighborhood level in our brain. In your work, are you looking at that allostatic load and looking at behaviors of sleep as well? And what's that picture looking like as well?
Yeah, so definitely not an expert on sleep in any shape or form. And I've never directly studied sleep. But a few years back, we conducted a study looking at cortisol awakening response. That's a highly biologically determined and stereotypic response. So when we wake up in the morning and measure our cortisol from saliva, just as much as from blood, and then measure it again 30 minutes later, there is a rise in cortisol. And that is called a cortisol awakening response. And we should all have that because it seems biologically this helps us to prepare for the day. So it increases our system's ability to respond to the challenges coming during the day. So when we were doing that study, one very important variable we had to deal with was the sleep the night before. Because it's long been known that sleep quality and sleep length influences our biology in many, many different levels. But in our particular study, it is known that it influences the stress hormone response. And therefore, we just mentioned that these stress hormones are highly biologically active. So even through that, sleep can have a considerable effect on our physiology. But the picture is a lot more complex because sleep deals not just with one system, sleep deals with our whole brain and likely to be our whole body at the same time. And sleep research is going to deliver in the near future some really, really exciting findings. Just a couple of years ago, it was discovered that there are special vessels in the brain that are responsible to drain the chemicals, the toxic chemicals out of the brain during sleep. And it's long been known if we prevent an organism from sleep, we can kill that organism. We can kill a man, we can kill a mouse by preventing sleep. Therefore, sleep must be something physiologically very important.
It was only today that I read a publication recently released around observing the role of sleep and how early stages of Alzheimer's, they were finding tau inside the cells of the part of the frontal part of our brain, which was impacting the ability of penetrating to deep sleep, where they're observing that pulsatile function, which is this wave-like function, folks, of how the brain is flushing out these toxic chemicals, if they're left there, the byproducts of being awake during the day and performing during the day and dealing with stress during the day. And they observed that early markers associated with Alzheimer's type dementia saw a change in sleep pattern as one of the key signs associated with it, and how it disrupted that pattern of behavior compared to healthy adults.
Yep.
So I'm fascinated by the space in sleep as well. I'm super grateful, Zoltan, for your time today.
My pleasure.
We've covered a great amount of territory of obviously lifting or revealing, pulling back the curtain, so to speak, on such a beautiful, complex system that we're starting to just trying to understand how our brain, whole body, the environment, including the bugs in our tummy, influences this wonderful thing called you and I. It is such a dynamic, multifactorial relationship, which challenges us to think about therapeutic strategies and how at times drugs don't have the impact, and how genes are not just the sole issue, but there are many variables at play. We've highlighted how our environment represents one of the key potential levers to influence our health and well-being and across our lifespan. And we've spoken about the general wear and tear, the allostatic load, and how that influences and is strongly associated with mental health and what we can be doing about it. You referenced some work there also in longitudinal studies looking at elderly folk as well who are experiencing high allostatic load and how that affects their cognitive performance. This has been a rich and wonderful conversation, Zoltan. And
Thank you very much, David. I enjoyed it a lot.
Yeah, and what we'll do is we'll include some in our show notes, some of the links to those articles that we've referenced in our conversation for folks should they want to go deeper. I'll also point them in the direction of your work there at James Cook University, which has a good bibliography of some of your papers there. Zoltan, how can folks stay in touch with what you're doing, your research, etc., and should they want to follow some of your stuff that you're doing?
So I'm not very good at some of the social medias like Twitter and things like. I do have a Twitter account, but I'm not a big user. My university research website contains a lot of information about what we are doing in the lab, and it also contains my email address. And I really would be quite responsive to approaches and questions and queries as much as my time permits.
And I should point out too, folks, that Zoltan's team and his team of emerging doctorates and those folk that are in the lab have got some fascinating projects that they're doing. I'll just touch on briefly. The last time I heard one of your team members speak was around the role of ketosis its impact on folk living with schizophrenia. So there's some fascinating work there, guys, that should you want to dive deeper into Zoltan and his team's work, and especially around some of the work emerging around allostatic markers and the index and how that's associated with cognitive performance, experience of mental health is a fascinating space and something that we'll continue to learn a lot of. Professor Zoltan, thank you very much for your time. And
thank you very much, David. Thank you.
I look forward to following your work in the future, and hopefully we might catch up with a conversation in the future.
Would be great. Yeah.
Okay.
If you really enjoyed today's conversation and have enjoyed other conversations on the podcast, Memory Health Made Easy, come on over. And I'm super excited to announce, ready, drum roll. That's right, I've got a Facebook group, Memory Health Warriors. A Memory Health Warrior is somebody who wants to turn up for themselves, their family, and their community, to have abundant energy and to play life fiercely so that we can have a beautiful brain for life, for memory health for life. The tribe's mission is simple. We're going to achieve 1 million beautiful brains, healthy, gorgeous brains, so that we can have memory health for life. And it's for folk who want to go a bit deeper with the content around the stuff that we go through here on this podcast. So join me over on Facebook at Memory Health Warriors. That's right, plural. And come and see what it's all about. Until next time, I'm your host, Dave Norris, and this is the Memory Health Made Easy podcast. Thanks for listening. Well, there you have it, folks. What a great conversation with Professor Zoltan Sarnyai. If you've enjoyed today's conversation, come on over to memoryhealthmadeeasy.com and have a look for the show. In it, you'll find resources and obviously conversation points that are maybe helping learn, revisit, compound, and apply these learnings into your life. I'm your host, Dave Norris. Thanks for listening, and I look forward to having a chat soon. The purpose of Memory Health Made Easy podcast is to educate and to inform. It is no substitute for professional care by a doctor or qualified professional. This podcast is provided on the understanding that it does not constitute medical or personal professional advice or services. Instead, we would encourage you to discuss your options with a healthcare provider who specializes in your particular needs.